You have a MacBook Pro. This is 13 inches, and this is a form factor that Apple introduced in 2016. So Apple has the non-touch bars, the 2016s and the 2017s only. So the model number of this is A1708. So whenever you see this, it's non-touch bar. It has no touch bar and it has no touch ID. So we usually will refer to it as a non-touch bar. But the model number is A1708. The description says that it's not charging. So you guys just saw that you have the low battery sign, but the device is not charging. So I'm just going to see that. So we have trackpad feedback, but yeah, you see that, but the device is not charging. So what we are going to do is we are going to plug charger to it, even though that's not really what we would do. The exception is because the device still starts, so we hoping that it is semi okay-ish to connect power to it. So what we are going to do is to plug power to it. First and first, we just want to confirm that charger is working. Okay, charger is working. Okay, so let's see. On this one, it has 2 ports, and the non-touch bars, they have 2 ports, not 4 ports. The 4 ports are the A1706s, which are the touch bars. So we are going to connect charger to it and see what happens. And nothing. Even though this has 2 ports, remember it will have 4 channels, channel A and B. So which means if we try it this way, if it doesn't work, we can flip it the other way, and we are still on the same port. So if that doesn't work, we are going to try the next port. Okay, let's try the next port. Now, unlike the A1706 that uses a wired USB-C charging cable, so the charging port itself is wired, the A1706, the charging port is soldered directly onto the board. So if this was like, say, like an A1706, which is the touch bar version of 2016 and 2017, you probably say, okay, fine, we can easily replace the DC jack, which is a USB-C charging port. But with the A1708, the DC jack is soldered directly onto the board. Okay, so we see that the device is still not charging. So now let's take the board out to see what is it that it's happening inside, and we'll take it from there. Now, because this is self-explanatory in a way, in terms of our focus is going to be primarily on the input, because that's what we're having problem with. So the input meaning, so let's open up the board view. Now for this one, the board view, what's happening here? Let's quit that and start again. Now there are 2 board views. There are 2 board views for this one. You have the 820-00840, and then you have the 820-00845 or 845. I'm just gonna. So one is a 2016 and one is a 2017. Let me see. So you have the 840, which is 2017, 820-00-840. That's 2017. That is 2017, and the 855. Let me see. Is it 855 will be 2016? 820-00-845. Is that no? Not 845. Is it 855? No, not 855. So the 2016 has a different board number. I'm just going to get a 2016 board. So it's 840. It's 2017. 840. 840, 840. This is 840. Lots of 840s. 840, 840, 840. Okay, 875. Yeah, 875. So 875, it's yeah, that's the 2016. Do I even have that? Yeah, I do. You can use a 20, you can use the same board, you can use the same board view for 2017. It's going to work 100%, so you won't really actually notice any difference in both. So this is the 2016, this is the 2016, and then the 840 will be 2017. Yeah, so let's quickly put this aside, and the two board numbers that you are going to expect on this one is going to be 820-00840 or 820-00875. 75 will be 2016, 840, 40 will be 2017. Okay, let's take out the back cover. We are going to use a pendulum screwdriver. We start from the right, and as you know, the screws on the right, the screws at the back will be longer. Say those are longer, and then this should be slightly longer if it's factory. No, that's not factory screw. That's not screw from factory. Actually, this are screw for 15 inches. So those are 15 inches screws. And then so this two are supposed to be here, the sizes, and then you have slightly longer one with a different thread, with a different threading than this one that we have here. So this here is for 15 inches, and this, yeah, so basically these are not factory screws, but this here are for this. Anyway, that's not really relevant. So the next thing we want to do is to take out the back cover. So we can either use a suction cup, but I just do it my way. Okay, interesting. It seems like it's okay. So we see, to start with, the trackpad cover, which is the cowling for the trackpad cable, that is missing. We have a couple of screws for the Wi-Fi module missing. We have the screen cable cowlings, they are both missing. Okay. Anyway, that doesn't look okay. And what is the board number? And this is 875. So this is a 2016 and not a 2017. I'm gonna show you guys the board number sec. Okay, so let us now disconnect the battery cable. Disconnect the battery. So this is the battery data cable, which is, so we disconnect that. Now we should have no more power from the battery onto the board. Now we are going to plug power to it to see what we get. Let's see if disconnecting the battery will make any changes. And doesn't make any changes. Now let's see, what do we, okay, so we are just quickly gonna, ideally what we want to do is to see the voltages that we get on the board, but let's just quickly go ahead and take the board out. Okay, so I see some components have been ripped off of the board. I'm not sure why that is, and I'm not also sure how that can be related to what we are looking at. Okay, let's quickly take the board out. So first of all, we are going to use our T5 screwdriver. Some of the screws are not for the machine itself, but yeah, that's completely wrong. Yeah, also that is not for, yeah, that is wrong as well. I'm not sure where this has been. That's a wrong screw. Although that's not in itself a problem, but yeah, just use the right screw. Okay, cable screws are out. Let's now quickly disconnect the cables. Okay, the board is out. I'm going to show you guys the board number. So I hope you guys can see that. That's the board number. So it's 820-00875-A. Can you see that? Okay, so that's the board number. And this is a 2016 version of the A1708. Our concentration is going to be on the input, which is a CD3215s, these two guys here. We don't, and also, and then again, obviously, you also want to look at the charging port itself. The charging port looks clean. It's nothing that suggests the problem is from the charging port. Nonetheless, we are now going to our reading is going to be concentrated on the CD3215, okay, which is these two guys here. I'll show you. So, first and first, we are going to start from U3100 and then move down to U3200. So first and first, let us see if we have a short around U3100. Remember, we say when you are looking for a short around the CD3215, you want to look at the LDOs. LDOs, for example, I want to look at PP3V3 underscore UPC. I want to see if that is shorted. PP3V4, PP3V3 underscore G3 hot. Let me see. So that is going to be that is going to be a power from PP3V42. So I'm not really going to worry about that because that is definitely present. If that was not present, you would not have the machine wouldn't even start to tell you that you have a battery low. I mean, the battery low signal will not be excited. So that we are going to check that, and then on this one as well we are going to check that, and then also we are going to check the fuse to see if maybe we have a short on the main on the PPDCIN line. So we are going to use this guy here because it's very loud. So we're setting our multimeter to continuity mode. So first thing first, let us see what we have on C3108. So C3108, let's see what we have there. And C3108 is going to be this guy here. And so, as you know, whenever you're measuring for a short, you have to make sure that you don't have power on the board. So first and first, just to confirm that our multimeter is set to continuity mode. We get the beep, that's what we're expecting. So we are going to have a black probe on ground and then our red probe on. Okay, we don't have a short on that. Now let's check the second one here. We don't have a short on that. And then let us check the fuses. So make sure the fuses are fine. Don't have a short there either. We don't have a short there either. Okay, so and let's just see that. No. Okay, so we don't seem to have a short, then it's safe. So we can just go ahead and connect power to the board. And now we want to see what voltages we have on each of this. So let's start from the top. Now we are going to use voltage mode because now we have power on the board. Black probe on ground, and then red probe. We want to see what do we have on the same C3108. We want to see what voltage we have there. The C3108 is this cap here, and we have 0. Okay, so then let's see on the other one. What do we have? Okay, so this is going to correspond with this, while this port will correspond with this. So it's this and that. So black probe on ground, and then red probe. What do we see? We see that we are getting 1 point something. Now the question, now do we have 5 volt at least? We don't seem to have 5 volt. And then here, okay, we don't seem to have 5 volt. Now let's check with this guy. Let's check the other port. Do we have 5 volt? No, we don't. No, we don't. Okay. Same thing. We have in 1 point something. Okay, let's flip it. Check the other side. Let's try to, but none. Do we have anything? Okay, interesting. Okay, so we don't have anything there. Let us start. Let's check this out. Now remember when I said we have channel A and channel B. So we are going to look at the CC1 line and the CC2 line. So CC1 will represent basically channel A, CC2. So see where it says USB-C, USB CC1. So that's going to be one channel, and CC2 will be another channel on the same port. So on the same port, you have CC1, CC2, and then on the other side, you'll have the same thing. On the other side, you'll have exactly the same thing. You have CC1 and CC2, CC1 and then CC2 on the same one. Let's see. So what we are going to do is we are going to check those lines to understand what is going on. So let's open the schematic for that, for this board. A20-00875. And we are going to start with this guy here, U3100. So let's type U3100. So since we want to start with U3100, U3100, and then we are going to go to its CC1 and CC2. So U3100, basically all of these pages here, to give you the pages where U3100 appears. This show sidebar, we don't want that. Now we want to go next. Search again, U3100. Okay, it appears on 4 pages. So we go to next. We want to go to the chip itself. Okay, this is our U3100. This is the chip that we are looking at here. We have CC1 and then CC2. So what we want to do is we want to see what is happening on CC1 and CC2. So let's go back there. CC1 is going to be 94 and 95. So what is happening on CC1 and CC2? Because we see, so in this case, we are going to need a diode mode. We are going to use a diode mode. So we are going to get another board that works, and then compare the readings between that board and this one. Let's get another board. let's see. Okay, yeah, this works. I'm just going to show you guys that this works. So let's connect charger to it. This guy here should give us that guy. PPDCIN, we can measure on this fuse here, and we see that's 20 volt. And then, as you know, it says OL because we set it to 20 volt. So if we set it above 20 volt, then we should get it 20. So that's 20 volt. So that this works. So what we want to do now is we want to check the differences between CC1. So we are going to use R3550. We want to measure we want to see what we have on this side and what we have on that side. So we are going to switch our multimeter to diode mode. That sign there is continuity. We are going to switch it. That is diode. Now for diode mode measurements, as you know, we are going to use our red probe on ground, and then our black probe is going to be basically what we use to do our to be our guide. So that R3350 for the CC1 of this chip is going to be this guy here. So let us see what we have there, and that is going to be this here. That. So first, let's see what we have. So black probe on red probe on ground, and then black probe. What do we have on that side? We have 0650, and then on this one, what do we have? We have 0. Okay, that's about okay. And then on the other side, what do we have? 0771, and then on this one, what do we have? 0625. Small differences. Let's check that again. That's a bit high. 07, that's almost 800. 050. Okay, let's say it's 060, 0760, and then here, what do we have? 0625. Okay, that's fine. Let's we'll go back to that if it's something that we'll have to look into again. And then this one, so let's check the second one here now. The second one, that's going to be CC2. So let's see what we have on CC2, which is this guy here on this side. What do we have? 651, and then the other side. Yeah, that seems to be a bit consistent. I mean, it's about the same thing we got before on that side as well. So let's check with this one. So what do we have? That should be 620, and then the other side. Okay, about the same thing. Okay, now let's check the C11 of the other of the second chip, 3200. So C11, CC1, I say C11, CC1. So which is going to be this guy here, CC1. What do we have? 646, and then on the other side, about the same thing, 769, and then here 649, and then on the other side about the same thing. Okay, so what we want to do now is sometimes yes, you may get sometimes you may get a reading that seem a little bit different. That might be something that sometimes it might not mean anything. So what you want to do is you want to get like a third opinion. So this is like a first and then second. So we want to get another board just to be sure that the differences that we have across the boards are fine. We can use this one here. Yeah, we can use this one here. Let's see what we have on that board. Let's see if we have 20 volt on this one. Switch back to voltage mode. And yes, we do have 20 volt, and that's fine. So let us see. Switch back to diode mode. Let's see what we have on the CC line. 640 something, and then on the other side 6 something, and then this side 6 something, and then that side 6 something, then this side what do we have? 6. The other side same 6 this side, 6, and then on the other side is also no. Okay, you see that? Oh, it goes to 7 and it's increasing. Yeah. So mm, okay. I don't think that's a problem. And then on the PPDCIN line, what do we have on PPDCIN line itself? 0226, and then on this side 0226. That's consistent. Here we should no. The way the border is not working. This guy. Okay. So what do you have? 180, and that's low. Yeah. I mean okay. Let's check that again. So here we have 160 something. Okay, what do we have here? 202, and then the other one 205. Okay, around about same thing, but this guy says 163. Okay, and this guy, what does it say? 160. Okay, so what we want to quickly do is let's remove the fuses. So what do we because this is a fuse, whatever you have on 1 is going to be equal to what you have on 2. So what we want to do quickly is remove the fuse before we. I'm actually very I'm kind of a let me see. I'm tempted to just go ahead and replace the E3100, but that's not a brain-on type of approach to take. So let us remove F3000, which is the fuse that we just measured from, and then check to see what we have on both sides. So because if we check now to see if with the fuse out, to see if the low side is on the chip or on the side. Do you understand? So let's remove the fuse. We can actually remove, yeah, so let's remove the fuse. Where is a board that is not working? Okay, this is a board that is not working. So let's remove the fuse, see what we get. Okay, fuse is out. Now we want to see, because the fuse has two sides, 1 and 2. Let us, and each side is connected to a different line. So we see that the one here is connected to the CD3215, is connected to a cap, is connected to an inductor, but that inductor is not there. We have a diode as well. The inductor should be, yeah, that inductor is not present. So, but this is present, that is present, and that is present. So what we want to do, that is on the pin 1 side of it, and then on the pin 2 side of it is connected to a MOSFET. So we want to see which side of it has the low reading. So let's start first. Let's see what we have, what we measure on pin 1. Same thing, black probe on ground, and then red probe. That's going to be the pin 1. What do we have? We have 0.08 something. That's quite low. And then on pin 2, which is high. So you see that? So we now isolate it, and then we can now tell that our issue is not on this side, but our issue is on this side. So we can either have a problem with U3100, or we might have a problem with D3300. So before we remove U3100, let us remove D3300. Now, just so that you guys have an idea of what we should be having there. Wait, where is my fuse? Where did I put the fuse? Did you see where I placed the fuse? Did I place it on the board?
No, you placed it on the desk.
Okay. Let's see. Maybe it's stuck on. I didn't see it. Okay, we'll have to use another one. Okay. No, that's a cap. Like that. So that's the fuse. So I'm going to remove and give us an idea what we should have on the other side. Okay. While we are waiting for that to cool off, I'm going to remove the diode, that guy there. So I'm going to remove D300, D3300. I'm going to remove it. So while we are waiting for the other one to cool off, okay, that's off the board. Now let's come back to this board here. So we get an idea what we are supposed to have on the pin 1 of the fuse. Say we have 0.1, so we don't have like 0.0, no. So you have 0.138, and then on the other side, which is one, I mean that's even higher, so 2 point something, and then the other side we have 0 point something. But what we're having on this guy here, so we can let me just put that back. Let me put the fuse back, so that we see what we're supposed to get. Okay, yes, come in. So with this now, so with the diode out of the board, let's see what we have. You see that? That's quite high. So our problem is going to be the diode and not E3100. You see that? So that's high. So let's put in another diode. My boss, 1 minute. I'll be with you guys. How far now? Sorry, no base. So so we saw that we did 3300 out. We seem to have a better reading now. Just going to confirm that again. We seem to have better reading. Yeah, we seem to have better reading. So that tells us that our problem is not U3100, this is U3215, but most likely both diodes actually blew out. So D3300 and as well as D3400. So we are going to replace both. So first thing first, let us put back the fuse. So we are going to use a fuse from here. Let's try to do this. Okay, that's there, and then the diode. Then the other one, the diode, the second diode. Okay, give it a bit of time to cool off. Okay, now let us see what we have. Back to measure black probe, red probe on ground. We want to measure again to see what we have on CC1 and CC2. That should be dropping. And by the way, when your board is it's when your board is hot, just like this one now, the diode mode readings that you get might not be accurate. So you want to give you time to cool off before you. And again, let's see what is it that. Let's check what we had on our fuse before. 185. 180. Yeah. So I think that's around about the same thing that we had on the working board. Yes. What's happening? Wait. Okay. Yeah. Again, we expect a bit of changes. We expect it to be a little lower, but when the board is cooled down, it should be higher, but not. Okay. Let's check now. The board should be a bit cooler now. 185, 86. Was that what we were getting before? And this one? One. Isn't that what we were getting before? Mm, okay. I'm just gonna confirm something. Let's see what we have. Let's see what we have with charger plugged in. Switch to voltage mode. All right. So let's see this. Okay. So let's remove the fuses again because okay. Now let's see what we have on 1 and 2. Let's switch back to diode mode. See what do we have on pin 1 of the fuse. Now is that an issue? It's not possible that the diode we installed are faulty, is it? Okay, let's check. Let's remove the diodes. Let's check again. Now it's high. Could it be the diodes are faulty? Okay, let's try. Okay, now just to be sure, what else do we have on that line? So we have, this is not present on the board. C3304, it's not present on the board. B3100 is present, and then on the other side, the line is not connected to nothing. So it's just U3100. What is on that line is U3100, C333101. The fact that a bit's fine now with C3101 still on the board means the problem is not this. I mean, and then also this is on the board and it reads fine. But when we add that, then the reading drops. Okay, let's just check again. That's ground, no? Yeah, so that's ground. But the reading seems to be high now, but okay. Let's put another diode to it. Now this time, before we put in another diode, we want to actually measure the diode. So this, we're going to use that, but before we do so, let's see. Okay, let's use this. But before we replace it, first let's check, see what we have. The diode and the fuse, what do we have? 1.63. That also doesn't seem to be 1.6. Okay, let's get something else. Okay. Yes, yes. No, that's a working board. That's a working board. Okay, these are. Let's not use this one. Okay, we can use this. Let's see what we have on our fuse. 158. Okay, that's a bit. There is 158. Let's check. Okay, so what we want to do, let's remove one of the diodes to see what happens. So let's see if we can simulate the same, the diode and the fuse, and then check the readings. Okay, now let's see what we have on the pin 1 of this. Pin 1 of the fuse, what do we have? Okay, that's high, just like how that the other guy is high. So we are now going to use the diode from that board. So that way we can tell if and it has a polarity which you have to be aware of. Okay. So now I'm going to use that on the board here. Use that on the board here. Okay. And then let's put the fuse back as well. Okay, I think before we do that, let's leave the fuse out for now, and then compare the readings. So fuse is out for now. Let's see what we have on in 1 and 2. In 1, okay, 002 something, and then here what do we have? 1 point something. So so we need to take out, yeah, so our CD3250 need to go. So we can put that back. Let's put the die back. Our CD3250 need to go. Okay, so we can transfer from here. We're only going to transfer 1 for now. See if the readings will change. Give it a bit of time to cool off. And then we are going to check to see if we have give it a bit of time. And the reason why we are saying UTS-100 needs to go is so we did 3300 out of the rail. We see that the voltage seemed to be fine, but then it's once we bring back D3300, not the voltage, the diode readings seem to be okay. Once we bring that back, the diode reading drops. So what else is on that line? The fuse is no longer there. I mean, the fuse is not going to do that anyway. But if the fuse was there, whatever is on the other side of the pin 2 of the fuse might contribute to what is, because fuse the pin 2 is going to be equal to pin 1. So fuse is not there. L3300 is not present, is not populated on the board. C3101, it's on the board, even when D3300 was not on the board. So it's not going to be this, it's not going to be that. So the next possible culprit will be U3100. So U3100 has now been replaced. Let us see what we get with U3100 replaced. So let's see what we have on our pin 1 now. Interesting, because okay, it's increasing, which is good. Okay, it's good, it's increasing. Okay, yeah, that's increasing. So I give it a bit of time to cool off. Let's try again. Okay, now that seems to be fine. Yeah, so now we no longer have 0 something. So yeah, so we have to now replace the second CD32. But just before we replace it, let's just see what is it that we have on that side. That actually seemed to be fine now. So it could be that we only had 140 CD3215 that was causing problems on both. Yeah, it seems though. It seems so. Okay, so let's put back the fuse and then the other fuse on the other board. I think this is for the one we took out from there. Both fuses were on top. Okay, that's on. We are going to give it a bit of time to cool off. And just before we plug power to it, we just want to check on the LDO to be sure that we don't have a short on the CD3215 that we've just installed now. I mean, because it's a BGA chip, chances are that the boards underneath might have crumbled, so, and that will create a short. So let's just confirm that we don't have a short. Okay, that's good. That's supposed to be okay. That's fine. Don't have a short there, and then that side don't have a short. Okay, so that's fine. Now let's connect power to it and see if we have any changes. So to connect power to the first port. Okay, seem to be hot still. Nah, still very hot. Still very hot. Still very hot. Let's give it a bit of time. Okay, so while we are waiting for the board to cool off, let us see what was these components that were ripped off of the board. On the other side of the board, see what was ripped off. Okay, it's these guys here. Ah, okay. Okay, is fine. No, but this is important. Yeah, this two are important, but this one not so. But these two here are. Although they're not playing a role in the issue that we're having now, so we're not really worried. The issue we're having now, it's separate from that, so we're not really worried. Okay, I think we can now test it. First port, switch back to voltage mode. We want to see if we have 3.3 volt. If we have voltage in here, even if it's 5 volt, we should have 3.3 volt on a 3.3 volt line, which is going to be this guy here, L6995. We should have 3 volt here. If we have voltage on PPDCIN and voltage, so even if you get 5 volt on even if you get 5 volt on this diode here, you will have 3.3 volt on L6995. So if you have 5 volt there, it means you actually have something which we were not having before. So let us see, do we have 3.3 volt at least? We have 0 volt. Are we using the right? Okay, yes, we are. So what do we have? We have 0 volt. Okay, and this one. We have 0 volt. Interesting. Okay, so let's see, what do we have on, say, on the fuse? What do we have? 0 volt. And then that side, what do we have on the fuse? 0 volt. This is very interesting. Okay, let's check again this diode mode. What do we have on our diode mode? Okay, we have a short. Okay, so, and then the other one, let's see. That's very weird reading. What is that? No, that's not okay. How do you, wait, what's happening? Okay. No, oh, it's not on diode mode. Okay. I was wondering what's happening here. Okay, 185. And this guy here, that's about fine. Okay, we have a problem here. Okay, so that diode, I suppose, did that. So you see, there's the problem. There's something. There's a problem with this diode here. So not a problem. So by design, the way this diode is, it's the extension of ground on this diode. The extension of ground, the pad for ground, it's a little bigger compared to the pad for the main line. So this is extended. When you replace it, it has to flush in place. If you do not if you're not careful when you're replacing it, what happens is the pad for your main line flushes with the pad for ground, and then that will obviously create a short. So I'm just going to move that a little bit. I'm not sure if you can see it from this side. No, that one is on. Aha. So you see that? So that's, you see, that's the pad for ground. You see how it's almost double the pad for the main. You understand? So this is the main line, and that is, all of that is ground. So when you're replacing, you have just a small gap in between them. So the chances of that flushing into that is very high. So I suppose that has happened. So I'm just going to try to redo it. check if it still fails, then I'm just gonna replace it. Or I'll take it out and then reposition it, whichever. Okay, that seems to be fine. Wait, and the other side, is it increasing it? No, let's just remove it. Yeah. Okay, we're gonna use another one. Let's check it now. Okay, that seems to be fine. Let's use another one. We can use this guy here. Okay. Doesn't seem straight to me. Okay, seems straight enough. Let's see. What's happening? Was that the one we did? I think that was the first one we removed, correct? I think so. That was the first one we removed from the board. Okay. Let's get another one. Just to be sure. Okay, let's take from here then. Okay, let's see what do we have now. It's very strange. Is it increasing down? Okay, that's fine. Should be increasing the more. Yeah, that's fine. Okay, that's fine. On the other side. We kind of back the same thing we had before, correct? That was 0 point something. It's increasing, but okay. Okay. Okay, it's increasing, and then the other one. Okay, so just let that cool off. Who might take you, Navi?
Not too much.
Let's see. Board should be cool now. Yeah, that's about fine. Okay, so let's see what we have. This guy here. Back to voltage mode. Black probe on ground, and then red probe on PP3V42 line. 0 volt. Okay, and PPDCIN line 0 volt. And then on the other one, what do we have? It's interesting. Let's see. What do we have? Let's check again. Let's check. See if we have any changes. That's fine. And then you? That is fine. Okay. So on both channels, we don't have nothing. Zero volt. And then on the other side, what do we have? Nothing. Okay. Nothing. Nothing. Okay. Let's check again for short. It's just to be sure that this charger is still connected. Yes, it's still connected. Charger is connected. We have 0 volt. Okay. Okay, let's try something. And this guy here. Check for short. We have 3.3 volt. Yeah, we do have 3.3 volt. That's 3.4 volt is present on the board. Okay, so what we are going to do is let us take out one of the CD32. So we did replace one, but we're not sure if it's our guy. This is our guy. Okay, so we did replace one. So let's take out the other one. Let's see if the other one somehow is also affected. Because before now, what was happening? I mean, we had similar readings across, but when you replace one, for some reason, the reading started to become. I mean, we started to have the same reading, so we thought, okay, maybe one of the CD3215 was basically causing problems on boards. So okay, yeah. So with that out, let us see what we get. See if we at least get a input on one of the port. We have 5 volt. We have 0 volt. Interesting. So we have 0 volt. We don't have a short on the line. So if we have replaced the CD3215 and we still don't have. Okay, so let's quickly replace this MOSFET, this guy Q3100. You can take it from, yeah, I take it from here. I'm actually curious how this will behave without Q3100. See how it behaves without Q3100. Do you at least get 5 volt? Yeah, you still get 5 volts. Just yeah. Yeah, just wouldn't go past it, but you still get 1 volt. You still get a 5 volt. Because our guy here, it's not. You don't even have 5 volt on input. Okay, so if we don't have 5 volt on input and it wouldn't have been a faulty CD3215 because we've replaced the CD3215. The next thing will now bring us to, and we don't have a short on that line. Just gonna confirm that again. So the next thing will be for us to replace the charging port. Why did it drop again? Okay, it's increasing. Okay, so So the next thing will be for us to replace the charging port. I mean, yeah, so okay, let's push this on the side first. Let's quickly replace the charging port and take it from the charging port. You need to go. Place something on to hold the board. Okay. Let's get a can get one from seem to be broken. Okay, we can use this one. This seems to be intact. It's easier to take it from the bottom here. I mean, especially the one that you want to use. So let's take it from the other side. Just because we want to make sure it's safe, so we want to take it from the other side. Okay, and then now we just have to take it from this side. Okay, that's on the board. Okay. Not properly in yet. Still have to. And also, it's easier also if you install it from the other side, just like the way we took out the charging port from the other side. So it's also easier to remove the shield and take it out from the other side. So remove the shield and install it from the other side. Let's see. Okay. Okay. So let's see if we have any changes with the charging port replaced. This is very interesting. This is another charging port, and you still have nothing. Okay, let's try and connect a cable to it. Let's see what a cable, a cable from another machine. Let's see what that would do. Wait, wait. Is it true? Okay, let's see. So at least we get 5 volt from the port, which means my charging port is fine, and we should have 3.3 volt now. Maybe this, what do we have here? 5? We don't have 5. It doesn't open. Let's see. It's not. Ah, ah, yeah. The chip really threw us off. This guy here threw us off. This guy here, U7000. Ah, that was so annoying. Ah, okay. Can't get from. Hmm. So the battery and charger IC, it's going to basically it's going to behave differently when you connect power compared to when you connect a USB device. So it's going to see that as a USB device. I mean, we connecting that as connecting cable from another machine. At least we can confirm that indeed the charging port itself is working, because I mean we got 5 out of it. So which also would mean that this charging port here, it's, I mean, we didn't really see anything wrong physically with it, but then we never thought about U7000 at all. Like, we completely forgot about U7000. Okay. So let's see now what we get. We are still not gonna, so we're gonna use this guy. Still gonna use the cable. See what we get. Is the cable from another machine. We're not connecting power yet. See if we have 5 volts. Yes, we have. VP3, V42. Wait. Okay, let's see. What do we have here? On this side. On that side. 1.8. Okay. So let's connect power now and see what we get. Okay. We have 5 volts. Okay. Let's quickly check something. Is U7000 properly installed? What is the time now? Hmm? 3 minutes past 3. Now we have a short on this guy here. But why doesn't it? This guy's there. Oh, wait. Oh, yeah. So we have a short here. No? No, not that guy. It's this guy here. If we have a short there, yes, we have a short on this side. And what is on that side? And then what is here? PP. No, we cannot have a short on PPDCIN. It said we didn't have a short. Do we now have a short on PPDCIN? We still don't have a short. So what is it saying? Wait. Okay, let's go for Salah on the Commodore 1707 board. It's been quite a bit of a roller coaster. Okay, so where are we? We are by U7000. The reason why we had replaced U7000 because U7000 was getting warm when the cable, the charger was connected. So we have replaced U7000, but that seemed not to fix the issue. But again, what we found was I measured a short on this line, and let me see. So let me see. Let me see if that short is coming from the board or from the U7000 that we replaced. Oh, it's not on. Okay. Continuity mode. Okay, let's see. Do we have so we are going to check for a short here now. Can you see that? Not there. We are measuring. They've seen what you want to measure, but and this one you saw it as well. But you seem to be far. So okay. Okay, so we have a short there. So we're quickly going to remove E7000 to see maybe if E7000 is the E7000 that we put there. It's probably not properly installed. So let's take that out and check again. Okay, E7000 is out. By the way, all of these chips, they have orientation. So for example, you see that the red pin there, that tells you that is the pin 1 of the chip. And then on the chip itself, you will find a small, on the actual chip itself, you find a small dot on this side. That dot will signify that is the direction of pin 1 on the chip. Okay, let's see now with the E7000 out, see if we still have a short on that line. Okay, we still do have a short on the line. So it may be that the first E7000 that we took out was not faulty. It may be that it was only getting warm because of the short on that line. Now let's see what we have on that line. What do we have on that line? So on that line connected are C7T21, R7E21, and C7E23. So let's see on the other side. On the other side, yes, maybe again. Okay, let us remove. Let's remove these two, 1 and 2. First, we take out C7021. Just move it out of the way. Let's check that again. Okay, that's not a problem. What we are now going to do is, instead of taking that out, because I doubt that's the problem, we are just going to move R7021 because that is most likely a 0 ohm resistor. So what that will mean is whatever it's on pin 2 is going to be equal to pin 1. So if we have a short here, if we have a short on this side, it could also be coming from this side. So if we move the resistor out of the way, then we'll have a gap. Then we can determine if the short is contained here or it's coming from this side. So we are just going to move this. So instead of removing this from the line, we already moved this from the line. The line we're talking about is so 1, 2, 3, 4 is the line that we're talking about now. So there is a short on this line. We want to find out where that short is coming from. We remove this cap from the line, and we still have a short. Now we have this on the line. This is not there. E7000 is not there. Then we have this and that. But then this is also a bridge of a different circuitry, which is this, correct? So we are going to move R7021, which would then give us, so if we move R721, if we still have a short here, it means that the short that we have, it's definitely coming from this guy. Because I mean, if this is not is out of the way, and we still have a short, but so let's, instead of removing this guy, let's move R7121 off from the line. Okay, that is moved from the line. Now let's check again. Okay, so now the short is gone. So the problem is not The problem is not here, the problem is from the side. So let's put put this cap back and put that back. Okay, we might just hold off on that, but let's put that back. Okay, that's there. Now we want to see what do we have on that side. So when we click, let's see what we have on pin 1 of TBA and the CSI. By the way, CSI will that is the current sensing line for your charger. So when you see I, that will signify charger, and then when you see that there is the other one, which is CSOR, that will be for your battery. So when it is I, that's a current sensing line for your battery, and then this side, the CSO, that will be the current sensing line for your charger. So let's go back there. So let's see what we have on the other side. On the other side, so we're going to click on pin 1. That's where we find that the short is. It takes us to R1790, R1720. So R1720, it's a resistor. Now whatever we have on pin 4, whatever we have on pin 3 is going to be equal to pin 4, which will be fed by pin 1. And okay, so pin 1 is going to come from and then let's see, which then will feed pin 2. Let's just confirm that. Interesting. Okay, so so let's see, but what I don't understand is we did check for a short on this line. It says no, I don't think we did. No, we didn't. We only checked for a short on this line. We didn't check for a short on this line. Yeah, we didn't check for a short on this line. We only checked for a short on. We checked for a short on this line, but we didn't check for a short on this line. Okay, so now let's go back there. Let's go back to where we left off. Okay, we're back to where we left off. So let's see, do we have a short on PPDCIN? We only checked at the fuse, we did not check. I see. So left probe on ground and then right probe. Yeah, we have a short. Okay, we missed that. We missed that. So there was a short on PPDCIN, but then we only checked this side, the input of the MOSFET. We didn't check the output of the MOSFET. Wait. So Q3100. Let's quickly go to Q3100. Let me let's see something. So Q3100. One and 8 is going to be the output. Yes, we did not check the output. Yeah, 1 and 8. No, 1 is going to be the gate. What am I saying? Yeah, 8. Yeah, 8 is the output, while 1 is going to be the gate. So we didn't check the output. So yeah, we only checked the input, which is we only checked the input from the fuse, but we did not check the output. We checked the input from the fuse, but we didn't check the output. So we have a problem on the output. Okay, so let's quickly find out where the short is coming from. So we are going to on that same line, and the same line of Q3100 is the same line of Q3200. So if you have a problem, we did replace this, but we did not replace Q3200. What else is on that line? What else is on that line that we potentially might have problem with? Okay, we did replace with 3100. Now let's replace with 3200. Okay, that's it, 3200. Let's see. We still have a short. Okay, let's remove V3100 as well, because you never know. Maybe what we had was, yeah, let's remove it. Okay, we still have a short. So you see now, that is the input. Wait. Why do we say you have a short on the input now? It's going on. We didn't have a short on the input, so why do we now have a short on the input? Okay, so it was just because the board was still hot. Okay, so we will still have a short on the output. So let's see what is there. If we click, let's quickly use a different. Okay, we can use this guy here. Okay, so this is where we have a short. This is out of the line, that is out of the line, that is out of the line. What if our problem is the U3100 that we installed? Maybe it was not properly installed. Or what else can be on that line? What else can be on that line? This is a resistor. Let's see. Let's flip that. What else can be on that line? What else can be on that line? PPDCIN. What else can be on that line? We can also save ourselves the trouble by just injecting voltage, but no, that will be like a shortcut. So what we can quickly do is we can remove R7090, R7020, just to give us a divide to know if our problem is on this side of the board or the problem is coming from that side of the board. So so if we remove R7020, it will give us, let's see, do we even have R7020 on the board to start with? Let's put this components to the side. We are going to come back to all of that later. We are going to replace all of that. So first and first, do you have R70 on the board? Okay, yes, we do. So let's remove that. We have it on the board. Now, if we remove our R7020, that will give us an idea. Then we will have a divide between pin 1 and pin 2. Now, while it is on the board, whatever is on pin 2 is going to be equal to pin 1, pin 1 is going to be equal to pin 2. So we are going to remove our R7020 to get an idea where the short is coming from. Okay, R7020 is out. Now let's see, where is our short? Is it on 1 or 2? So let's see. No. Okay, so the short is on 2. So which means everything on this side, it's okay. Everything on this side, which means everything here, it's fine. You don't have a problem there. We don't have a problem this side. Where we have a problem, it's going to be on this side of it, the pin 1 of it. So we either, let's see, and then on the other side, okay, so this is where we have a problem. Okay, this is a very interesting board. Okay, so we have so which is it going to be? Is it going to be one of these guys here, or is it going to be Q7030? We can just easily inject voltage and then to give us the answer, because when we inject voltage, whatever component that is passing power to ground will become warm, and we can easily pinpoint that. So where do we start? So do we start by removing this guys here, or okay? Another thing is, you see here, R6990 is a resistor, which would mean even though let me see. Yeah, this is not a 0 ohm resistor. R6990 is not 0 ohm. Let's quickly check that. R6996 is not 0 ohm. R6996 is not 0 ohm, is it? Now it's 47 kilo ohms, so it's not 0 ohm. So what that would mean is, if we check the other side of the resistor, so let's see the other side of the resistor. Uh, okay, that resistor is not so. Okay, let's remove that resistor. Just move it aside a bit. Okay, we're trying to isolate to see if the problem is on one side or the other. Okay, so the problem is not on this side. The problem is definitely on the other side, this side. Okay, that's fine. That's fine. We can put that back. Let's quickly push back the resistor for current sensing before we forget it. Okay, so we know our problem. So we know that our problem is not on this side. We know our problem is contained within this side and this side. So do you remove Q7030 or start by removing the capacitors? So let's just quickly start by removing the capacitors. Let's see if one of them might have failed. Are you not getting shadows from my arm from that side? Okay. So we can read the capacitors. We can read the individual capacitor. I mean, that's a quick way, and that's one way for of not getting. By the way, these are polarized caps, so they have polarity. So they will have a particular orientation. So what I'm going to do is I'm going to read across the capacitors. Whichever one beeps will tell me that that one has failed. That doesn't beep, so that is fine. That doesn't beep, that's fine. That doesn't beep, that's fine. That doesn't beep, that's fine. That is fine. That is fine. So none of the cap is my problem. So we should still have a short. Yeah. So which then takes us to Q7030. Yeah. Okay. Let's quickly put those back. Let's orient them the way they should. Okay, now we are going to remove Q1730. Okay, that's out. See if we still have a short. Okay, so Q1730 is out of the line. Okay, so if that is out of the line, let's say, and then we took those out and we still had a short. This is not there, we still have a short, and what are these? Are these caps? Okay, now let's check these two guys here and these two guys. So most likely what is left. So since we are on this side, let's check these two here first. So let's move those. So when I got burnt, the heat that I felt was not from U7000, but from one of these guys here. So the problem all along was one of these guys here. So either that one. So one of them failed. So let's read across them to see which one it was. That was our problem. So it's not supposed to be on both sides because by design you're supposed to have a form of insulation which is materials that separates this pin from that pin. So this is how it should behave, like this. It should not be because of the material installations in between, but this one behaves. So that is our problem, and this guy threw us off all through. Now this board is so disruptive that we cannot tell exactly if that was the only failure all along, or if we have. This is just, yeah. Let's start to put back all of what has been taken off. That was we can use that. Now we can just grab another one. Okay, now let's put our E7000. Need to go back. Where did we place the E7000? E7000. No, that's Q. U. I'm talking about this guy here, the one that we had two. Yeah. So orientation wise, I'm not sure if you guys can see that, but I'll try to show you. Okay, let me do this. If I add a bit of that to it, maybe you'll see it easy. I'm not sure you can pick that up. It's coming. So you see there should be a dot, a black dot. No, you cannot see it still. See, there should be a black dot here. Okay. Now, do you see it now? No, you cannot. Okay, so in any case, look out for a black dot underneath this side. So that is going to indicate your pin 1. Uh, okay, stay there. Let's make sure that so one way we can orient it is just by, so we do it twice. First, we orient it by pressing down the chip. That will help me like that. And I'm trying to make sure the balls underneath are even. And then I'll remove it and then do it for the second time. That tab doesn't seem to be properly installed. Let's do that before we. Okay, so now we can put back the chip. The first time is just so that I can properly align. I can work on the balls underneath the chip. So that is how I manually reball the chip. So I just have to do like a manual reball of the chip. Okay, we're going to clean that off. And this guy. Okay, so on the other side, we need to put back that guy first. Should be the other way around as well. Then this can go back. Okay, that's that. And then these guys need to come back in place where they belong. These ones are easy to align, you can clearly see it. So let's put back the CD3215. This one, this is very big to see. See that dot there? That signifies it's pin 1. I hope you can see that. Yeah, so that's how you can tell. That is pin 1 of the chip. It doesn't seem like it's properly installed. We might have to redo that. I wasn't supposed to move it. The fact that oftentimes when you move it, it disrupts the balls underneath the chip, so which would then create a short, and yeah, and then would most likely not work. So we might have to redo that one. But first and first, let's see what is it that we took off that needs to go back. Here it's all back in. Is your phone on?
Yeah.
I'm expecting that the other person that's supposed to have phoned you. Okay, so we may have to redo the CD3215 here because the way we pushed it, oftentimes when you do so, it disrupts the balls underneath the chip. So let's see if the chip is shorted. Sometimes, even though even if you measure for short, you might not quickly pick it up that it's that the balls underneath are not properly put in place. So yeah, wait, don't tell me. Okay, yeah, so if I take it out, you should see how crumbled the balls will look, because I'm very sure the balls underneath it are crumbled. You see that? You don't see it. You still don't see it. Does that look arranged? Look at this. Okay. Maybe you still don't see that. Look at this.
This one.
Can't you
Yes,
see it?
yes, I see. Mm.
You don't see how crumbled the
I
balls
see.
are and how arranged these are. Yeah, so that was so what we are going to do is we are going to do like a manual reboarding as well. So we're just going to place this chip back there, press it down, and that will manually do the reboarding. But before we do so, let's remove this. Let's remove that. Otherwise, it's going to be too much. Okay. So we are going to press this down, and so that will also help us to align the balls underneath this chip itself. You're not installing it now, we're just going to press it down and then so like that. Now we take it out. So you see now, see how it looks now. You see how smooth it looks. You want to check your phone? So now we can put the chip back. Make sure the orientation is correct. Okay, that's done. Now while we are waiting for the board to cool off, so let's go back to the board and start off, see what happened, where we got it wrong, and why we are where we are. So quit this and start over again. So what happened, and where did we get it? Where did we get it wrong? Yes. Okay, so we want to go back to where what happened and where we got it wrong and why we got thrown off. And in my troubleshooting, I did mention in my troubleshooting guide, I did mention that once you get thrown off, it takes you sometimes 360. Okay, so where where are we and where were we? Okay, so to start off, we were getting 0 volt on PPDCIN. PPDCIN, so let's go to our schematic. U3100, let's go to U3100. U3100, which is a CD3215, U3100. There are two of that on the board. Okay. So, okay, so it says make this single page. Okay, so CD32. This is there are two CD3215 here, and there are various regions of this chip. Now, primarily, we wanted PPDCIN voltage coming into the chip, and which from this point you have you have a MOSFET that needs to be opened, the gate of which is tied to U3100. You have input and then you have output. So when we didn't have when we had nothing on 20 volt on the side, we neither have 20 volt or 5 volt. So 5 volt is going to be the basic when everything is up and good. When the working condition of the circuitry are met, what will happen is the 5 volt will then go up to 20 volt. So we checked here, and then we were having a fluctuating voltage. So basically, we're getting almost nothing here. But on the LDO and on the LDO of this chip, we were getting on this here G1, we were getting less than 3.3 volts. So which suggests that there's a problem. We check for a short. So we checked for a short on the LDO of U3100, and that there was no short. We checked for a short there was no short. And then what we then had to do was, so we thought, okay, maybe one of the CD3215 is failing. So what we did was we took out one of the CD3215, which is actually this one. We took out that one, and then we tried and nothing, and then we took out that one as, okay, now this was the second one we took out. So we thought, okay, what is going on? That also didn't solve the problem. So we thought, okay, maybe the problem, and all the while we were sticking to the input, which is going to be, so on Q3100, for example, input will be on, let's go back to our fuse. So the input will be, so here, so this will be pin 1, and then pin 2, input will be tied to our, MOSFET. So let's go back. So we thought, okay, maybe we're having a problem on the diode here. We tried to address that, but what I don't even remember is, I don't even remember if we had, I don't suppose we had a short here. No, we just had a reading that didn't match what we had. So we thought, okay, maybe we have a problem with the diode. We removed the diode and then we put it back, and we were getting a short there, but that was from the installations. It wasn't that there was a problem. That was from the installations that we did. It wasn't properly done, or that the diode we took out from another board was not. But we had a problem there, which was not a problem that we were battling with. So we had to sort that one out. But then we were still getting 0 volt across. So we decided, okay, maybe. And all of those time, we did not move an inch to the other side, which is the output. We were just busy there. And then with this, the input is going to be equal to the output. So what that means is if you have a short here, it will prevent this, which would then prevent your voltage. So from PPDCIN voltage from coming in. So we decided, okay, maybe we have a problem with the DC jack. We replaced the DC jack, but also that didn't solve the problem. But then again, what we decided to do was we decided to use a USB cable from my connected device and just see if we can get 5 volt on, just to confirm that at least the DC jack itself, it's fine. And then yes, we did get 5 volt. We confirmed that DC jack is fine. And then I got burnt around this section here, and then I concluded that the problem was U7000, and then I went ahead to remove U7000, and then all the way I still did not know about the short on PPDCIN here. And because the reason why was because I concluded that there's no short on PPDCIN from here. That's where I didn't worry about. I did worry about that. And then when I removed U7000, but the problem was still the same. So we realized, okay, so what is going on? So we that's only when we started measuring around U7000, only then did we pick up, okay, that we are measuring, there's a short there. And then we removed C721. That was not the problem. We decided, nah, let's take out R721 because that will help us isolate. Oh, by the way, okay, yeah, we did remove that, and then we realized, okay, so when we did remove that, we then realized, okay, the problem is not from here, but rather the problem is on the other side, obviously because R7021, because of the value of R7021. So we went to the other side of the board, which is R7020, which is the current sensing resistor, and then here we decided to then isolate it by taking out R7020, because then we'll have a divide. Then we ask ourselves, so what is the problem? So when we remove that, we found that the short is on this side of the board and not on this side of the board. So we now started, okay, now, so what could be on that board? So we remove, before that we moved this, the capacitors here, the polarized capacitors here. We thought maybe they have failed, but nope, they didn't fail. And then we came back to remove Q7030. That was not the problem. And then we asked ourselves, what more is on the line? And what was left on the line, basically, by the way, we have also moved R6906 just to be sure that the problem is not coming from the other side of it. And that was not a problem until we found out that one of these guys has failed. And that took us all across the board. Okay, so now we've put back, the short has been resolved, we've put back all of what we took out. Now the problem we're going to have is we might have a problem in say the components that we have taken off that we put back might not be properly installed. As example, so I'll be looking out to see the performance of U7000, the performance of our both C32 R15s. I do know that I had taken out one of the C3215s, so which means that this one here, the one that I took out, the ones that I took out from here, none of them actually had a problem. So now let's connect power to it and see what we get. So just before we connect power to it, let's just confirm again that we don't have a short. We got really thrown off. Really thrown off. I mean, at the time when we connected power from cable from the machine to the board, we got 5 volt, but we didn't have 3.3 volt. And then I was asking myself, but wait, if you have 5 volt on input, you should have 3.3 volt because 5 volt is enough across this diode to give you 3.3 volt. But then I didn't also realize that, okay, there's because there's a short here, that's why there was no 5 volt coming in. Okay, so now let's connect our charger. Start from Bismillah. Start from the bottom or the yes, whichever one. Okay, so now charger is connected. Let's see, do we have 3.3 volt at least? I mean, if we have 3.3 volt, that will at least tell us that G7000 is working. That will at least tell us that CD3215 is working. And then we can now start to increase our hope. So first and first, let's see what we have on our PP3P42. and that's a beautiful 3.3 3.4 volt. That is good because that tells us that U7000 is working. The reason why I say that is because the enabled signal of use of PP3V42 is going to come from U7000. So U6990 is our PP3V42 regulator IC. Now the enable signal of that is going to come from U7000. You see, pin 10 of it, that is the enable signal, and that is going to come from U7000. So that's going to come from U7000. So the fact that we have 3.3 volt, partially we can say that U7000 is working. So now let us see, do we have PP bus? If we have PP bus, if PP bus is 13 volt, that is beautiful because that means we have 20 volt on our PPDCIN. 0 volt. So 0 volt means we have 5 volt. So let's just check again that indeed we have 3 volts still. Okay, we have 3.4 volt, and then PP bus, what do we have? We have 0 volt. So that means we have 5 volt across. So we have to most likely reinstall our CD3215. So let's see, what do we have? Yeah, that is 5 volt. It's 5 volt on this guy. So let's see. And then the output, what do we see? 3.4, 3.3, 3.4. Okay, and then this one here, do we have 3.4 output? Wait, let's try again. You see how that is fluctuating? So that can actually, so there are two ways. So that can be the good one because it's trying to boost to 20 volt. And then so what we're going to do first, we're not going to replace that first, rather we're going to replace that one first. Do you understand? So the fact that you see the fact that this is so this is corresponding with that, and that is going to correspond with that. So the fact that when you plug in, you have just stable 5 volt without fluctuation, that tells you that it's not trying to make its way to 20 volt at all. But the other one here, you should have it turning 5 and then 0, 5 and then 0. Should go down again. Yeah, so let's remove that one first. At least yeah, we're making progress. We're making progress. Yeah, you see also the balls underneath. You see the balls underneath here also crumbled. See, that's yeah, we also had crumbled balls underneath. So let's quickly address that. Hopefully that should be the last portion of our board. So let's quickly address that. We are going to do the same thing we did on this one here. Do you think the light is too much? But the reflection that you're getting, yeah, because it would make you not see. Okay, so that now the next thing we're now going to do is just do exactly what we did before today. So we press down the chip, take it off, and then to replace it. So that will help us to achieve manual reballing. Okay, that looks good. Now we're just going to remove the extra ball there, and then we should be good to go. Okay. Yeah. Okay. Now we can put back the chip. Do you have any extra? Yeah. Okay. Mm-mm. It's not properly done. Okay. Give it a bit of a time to cool off. Time is it? 5:36. I hope we wouldn't have to redo that. I'm not sure if it's properly seated, but if not, we'll have to redo it. So, it's one interesting board. Still very hot. We are going to wipe it when the repair is done. For now, we are just okay. Let's try again. Let's just make sure we don't have a short. That will also give the chip a bit of cooling time. Okay, let's see. First thing we want to check is at least do we have what we started with, which is do we have at least 5 volt on the chip? 5 volt there should give us 3.4 volt here. No, we don't. So we have to redo it. Okay, we have to redo it. And then on the other side, because it has 2 channels, let's see the other channel. Sometimes you might have one channel at least working and the other one not. Okay, so we just have to redo it. And then let's see what we have on the other one. 3.4 and then PP bus 1.0. Yeah, okay, so let's quickly, yeah, so the way it was looking, I wasn't confident. Yeah, so I wasn't confident the way it was looking. Yeah, so you see how, yeah, so you see still have extra balls. So I'm just going to press down on the chip one time and then take it off again. That will remove all of the excesses from the board. Okay, yeah, that works now. That works. We're just going to remove the excesses like that, and then we can put it back. Okay. 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 So that seemed to be. It seemed to look better than before. Okay. So now we are going to give it a bit of time to cool off. Even if we don't get even if we do not get 20 volt, at least we should have 5 volt, which is what we started with. So what time is it? 5:41. Yeah, need to leave for Sarah. What is? Yeah, I need to. Okay, I'm just gonna quickly test it. Still very hot. Okay, let's see what we have. We have 3.4 volt, 0 volt. Okay, we have 3.4. That's fine. What do we have on PP bus? Okay, we have to replace that. Now we have to replace it. We have to replace it because we are getting still 5 volt and stable, not fluctuating. The other one, we are getting 5 volt and fluctuate. Yeah, so we have to replace one of the cities. Okay, we'll have to continue that. It's time for Salah now. Okay, so we again had to replace it. The other one, this guy didn't, so it was misbehaving, so we basically had to replace it. And that was the one that would so what it would do, it would it just stays on 5 volt without trying to boost. But the other one was boosting, was trying to boost, sorry. So it will go 5 volt and then it will go back to 0. So usually that's one way you can identify that that's the one that is actually functioning, while the other one that is stuck on 5 volt is the one that is faulty. So we have this is the one that was not moving at all, so we replace it with another one, and that's the one that we replace it with, and that one works okay. So what we're going to do now is we are going to connect our charger to it to see what we get. Okay, the charger is connected, and our multimeter, let's see what we get. We are gonna place this black probe on ground, a screw hole, and a red probe. We can use this guy here, and we say it's clearly OL, and that's because, as you know, okay, I switched the multimeter to 200 volt. OL will be because the voltage that has been measured is higher than 20 volt. Okay, so let's try again. So we're measuring the diffuse, and as you guys can see, that is 20 volt. It's a beautiful 20 volt. Okay, so we are now going to so let's see, that's what we're measuring. We're measuring diffuse there basically. Okay, so what we're now going to do is we want to put the board in the shell and see what we get. Okay, so as you know, initially without battery connected it would not start. And with the battery connected it would just say it will only show the low battery sign, and that's about it. It would not start. And so what we want to do now is we basically want to test it. So we are going to leave the battery unplugged and just plug our charger to see what we get. The charger is connected. Do we have a fan spin? That's a beautiful fan spin. That's good. Okay, now let's see what we have on our screen. Do you have anything on the screen? And that's a chime, and that's a beautiful Apple logo. As you guys know before now, that's not the case, and that's it. So I'm not going to check the second port. So as you see with the the charger disconnected, the device goes off. So I'm checking on the second port. Do we have trackpad feedback? Yes, we do. So hopefully any moment from now we should see the device starting. That's a chime, and that's a beautiful Apple logo. Okay, thank you guys, and yeah, I will see you guys in the next one. So as you know, just a quick one. Okay, so all along, our problem was where is this guy? So this was our problem all along. One of the guys here, one of so between C7036 and C7034, that was where the problem was, and the reason why we didn't catch it was because we were obviously we missed it. We were not getting voltages at PPDCIN, and we were only interested in the fuse as well as the line on with the diode. But what we did not check was the PPDCIN line, and eventually it took us a very long time to realize that we actually have a short on PPDCIN. And then and then while also we were troubleshooting, I did feel something around here, so I thought the problem was U7000, so I had to replace U7000, but that still didn't fix it. So while then I started to basically I started to now read the components around U7000 to see why, and then I realized that we have a short on this line here, which is the current sensing line, and then we traced that further to find out where the short is coming from, and then eventually it led us to the other side of the board as well. We removed lots of components, but that didn't solve it until eventually we realized that we were able to narrow the issue down to one of these guys here. So because we took both out, and then we realized one of them was faulty. So I couldn't really pinpoint exactly which one of them was the issue. But nonetheless, the issue has been resolved now. As you guys can see, we have a working device. This is the device without battery being connected. I don't know if you guys can see that. You see, it is no battery connected. See that? No battery connected. And yeah, the device starts with charger. So with the battery connected, the device should start charging. And yeah, thank you guys. I will see you guys in the next one.